All right, guys, this is a review of proving triangles congruent. This is part one. What does CPCTC stand for? Well, it stands for corresponding parts of congruent triangles are congruent. What must you show in your proof, it should say, before using CPCTC? Well, you must show that the triangles are congruent. And what do you use CPCTC for in a proof? Well, like it says, corresponding parts. You use it to show that two specific parts are congruent. All right? Now, tell how the triangles are congruent using one of these postulates. If you want to state the given segments or angles congruent, be careful. Don't use those given segments or angles to help get your answer. I have no idea what that means. But let's just look and see by what postulate these will be congruent. So this first pair, you know what, let me zoom in. Okay, well, looking at these two triangles, I have a hypotenuse and a leg. So these triangles are congruent according to the hypotenuse-leg theorem. And then I could declare that these angles are congruent by CPCTC. Okay, but hypotenuse-leg. All right, so I think they were warning us not to mark C congruent to F, for example, and try to use that. We're just supposed to use what's shown. All right, so looking at number 6, I see it's a right triangle, so is it hypotenuse leg? No, the hypotenuse is not congruent, or it's not marked congruent. But in that case, what I have is an angle, and another angle, and a side. So this is going to be angle, angle, side. It cannot be angle, side, angle. All right, you would be wrong if you put angle, side, angle, because the side is not between the two angles. All right, if it had been here, then it would be angle, side, angle. All right. Anyways, number 7. All right, we have an angle, a side, and an angle. So this is going to be angle, side, angle. If it's going to be angle, side, angle, it has to be two angles and the side between them. And so here I have two angles and the side that is in between them. Number 8. In addition to the sides that are marked, we can also mark this shared side. TV is congruent to TV by the reflexive property. Anyway, so now I see that all three sides are congruent to all three sides. So these are congruent by the side, side, side postulate. Looking at number 9, in addition to what's marked, we can also indicate that these vertical angles are congruent, all right, by the vertical angle theorem. So that gives me side, angle, side. So this will be congruent by the side, angle, side theorem. Again, it has to be the angle in the middle formed by the two sides, and it is. Number 10. Okay, these are parallel. Please understand that these markings do not mean that the sides are congruent. It means that the top is parallel to the bottom, right? Okay, for example, these are parallel, and it means that these are parallel. All right, so the pink lines are parallel, and the blue lines are parallel. So let's look at one of those at a time. Look at the blue lines for a moment. If these are parallel, then if I make sort of a Z out of it, all right, I mean, I guess it's a backwards Z, but you get it, all right? If I make this sort of Z shape, this backwards Z, these are alternate interior angles. And if the lines are parallel, alternate interior angles will be equal. So there you go. But I could do the same thing with the pink lines. If I make some sort of a Z shape out of them, okay, that's going to look like this zigzag Z shape. And if I do that, then you can see that these are alternate interior angles. Okay, the corners of the Z, in other words, are alternate interior angles. Okay, so I can mark all of those alternate interior angles like I just did. In addition to that, what I have here is a shared side. So those will be congruent by the reflexive property. So let's see what we have. I have a side and two angles. All right, so is it going to be angle, angle, side, or is it going to be angle, side, angle? Well, I have my two angles. Is this side in the middle between them? It is. All right, this side is between the two angles, so therefore it's called angle, side, angle. Match each statement to its correct congruency method at the right. If we have right angles that have a pair of hypotenuses and a pair of legs, well, that is hypotenuse leg, that's E. Triangles that have two pairs of sides congruent and one pair of included angles. Okay, so that's side, angle, side they're describing. All right, they said two sides and the included angle. All right, so that's B. All right, for side, angle, side. Number 13. Triangles that have two pairs of angles congruent and one pair of non-included sides. Okay, so we're talking about two pairs of angles and then a non-included side. So that's angle, angle, side. That's D. All right, number 14. Triangles that have three pairs of sides congruent. Well, that's side, side, side. And finally, triangles that have two pairs of angles congruent and one pair of included sides. All right, so it's two pairs of angles, and then, but this time, the sides are between the angles. So that's angle, side, angle. So that's C. Which condition does not prove that the two triangles are congruent? Well, that's going to be this one. There's no side-side angle postulate. And it's a good thing, because what would happen if we wrote it backwards? That would make a bad word. Luckily, we don't have to worry about that. In the diagram of ABC and DEF below, okay, AB is congruent to DE. Okay, so AB is congruent to DE. Angle A is congruent to angle D. And angle B is congruent to angle E. Okay, so these are going to be congruent by angle, side, angle. All right, in the accompanying diagram of triangles, bat and flu, angle B is congruent to angle F. Shabam. And BA is congruent to FL. Which statement is needed to prove the two triangles are congruent? Okay, let's see. Let me switch colors here. So what if angle A were congruent to angle L? Okay, if A were congruent to angle L, would that prove that they were congruent? Yes. Yes, it would. Oh, wait, we got to be careful. We're trying to prove that BAT is congruent to FLU specifically. So we have to make sure that A is congruent to L, for example. And it is. All right, I mean, by this method, see how they're both marked pink? What else? What about B? B would have to match up with F. And it does. Okay, so yeah, that would do it right there. So A must be the answer. All right, let's look at one other answer to see why it wouldn't work, to make sure you understand the question. Okay, what if they gave us additionally that AT was congruent to LU? So that would mean AT would be congruent to LU. Well, this would be side-side angle. And like we said, that's not one of the postulates. So it definitely wouldn't be that one. All right, what if they gave us A is congruent to U? All right, well, if they gave us A is congruent to U, well, in this triangle, we're looking at angle, side, angle. But in this triangle, we're looking at angle, angle, side. All right, the side's not in the middle. So that's two different types of congruence. So that wouldn't work either. So that's the type of thing you have to do to eliminate the other choices. Okay, number 19. In this diagram, HK bisects IL. All right, so far, if HK is a bisector, then that means IJ is congruent to JL, because HK is cutting this in half. And angle K is congruent, angle H is congruent to angle K. Okay, so given those pieces of information, another thing that we know is vertical angles are congruent. So we have that as well. So over here I have angle, angle, side, and over here I have angle, angle, side. So the answer is C. Okay, if these two triangles are congruent and these two triangles are congruent, which of the following statements must be true? Interesting, okay? So it's like a sort of transitive property. All right, if this triangle is congruent to this triangle, all right, but that same triangle is congruent to a third triangle, then it makes sense that the first triangle must be congruent with the last triangle. So specifically, that means that angle A must be congruent to angle D, and angle B must be congruent to angle E, and angle C must be congruent to angle F. Okay, for example, so let's just look at these options one by one. Is B congruent to D? No, B is in the middle, D is first. Is TU congruent to EF? All right, TU is first, and EF is second, so no. Is angle A congruent to angle F? No, angle A is first, angle F is third, so no. Hopefully this last one is it, because our last option. I don't like to be wrong. Is AB congruent to DE? AB is the first two, and DE is also the first two. So finally, yes, D would have to be the answer. All right, let's look at some two-column proofs. All right, we're given that EF is congruent to GH. All right, so EF, GH. Also, FG is congruent to HE. So there's FG is congruent to HE. So far, so good. Now we're supposed to prove that the two triangles are congruent. Okay, so I see it says given right here, so I need to say one of the givens. I'm not going to say FG equals HE yet, okay, because clearly that's the second one. So it must be the first one. So I'm supposed to say that EF is congruent to GH. Which is given. And then FG is congruent to HE. Of course, that's also given. All right, well, what else do we have going on in here? We have the shared side. All right, so the blue stuff, that was given. But this was not given. G is congruent to E. I'm sorry, GE is congruent to GE by the reflexive property. All right, and now we can say that the triangles are congruent by the side, side, side postulate. All right, because all three sides are congruent to all three sides. Okay, in this one, SP is congruent to TP. SP, TP. PQ bisects SPT. Okay, if PQ bisects angle SPT, that means it is splitting this angle right down the middle. So angle SPQ should be congruent to angle TPQ. So those are the two things we're given. In addition to that, we also see that the shared side is congruent. PQ is congruent to PQ by the reflexive property. Now, at a glance, we can see that the triangles will be congruent by side, angle, side. So we'll keep that in the back of our mind, side, angle, side. So the first statement is just given to us. SP is congruent to TP. All right, that's the given. They also mentioned that PQ bisects angle SPT. All right, again, that's right out of the given. All right, and then they say angle SPQ, all right, that's this blue angle, is congruent to angle TPQ, TPQ. All right, well, that's just the definition of angle bisector. All right, they just said it bisects, and that's what it means, equal parts. So just say the definition of angle bisector. All right, next, I see by the reasons that they're mentioning the reflexive property of congruence, and that must be this other side, okay, the shared side. So that's why we're going to say PQ is congruent to PQ. All right, now the last statement always has to be the thing that you're trying to prove. So we're trying to prove that triangle SPQ is congruent to triangle TPQ. And like we said, side, angle, side. All right, number 23, here's another proof. This one doesn't have it all worked out for us, so we're going to have to actually think. Oh, no. Angle ABE, so ABE, that's this angle right here, is congruent to angle CDE. So CDE, that's this angle right here. Now, segment AB is congruent to segment CD. So there's segment AB and here's segment CD. Now, prove that segment AD is congruent to segment CB. All right, AD, CB. So these will be corresponding parts once we prove the triangles are congruent. So we have to start by proving the triangles are congruent. Well, in addition to the two things that were given, we also know that vertical angles are congruent. However, I'm looking ahead, and that's not actually going to help us. This problem is a tricky one. They tried to get us, but we're not going to fall for it. The reason why this problem is tricky, though, is because we don't really need this diagonal. And in fact, that diagonal is confusing the issue. So that's why I'm sort of erasing it. Okay, it's really these two triangles that we're dealing with. All right, so looking at these two triangles and ignoring that diagonal that was there before, we can see that these two large triangles have a shared side. So we can go ahead and show the reflexive property. DB is congruent to DB. So looking ahead, we have side, angle, side. Side, angle, side. So ultimately, we can prove that these large triangles are congruent by side, angle, side. Okay, so that will be our goal. So in fact, as we set up our work, I like to go in order. All right, so if I know that I'm shooting for side angle side, then I'm going to do that. I'm going to list a pair of sides, a pair of angles, and a pair of sides. That way I have side angle side. So first, do I have anything in the given? Yeah, I have a pair of sides in the given. So I can go ahead and say AB is congruent to CD. Reason given. Now I need a pair of angles. Oh look, that's also in the given. Angle ABE is congruent to angle CDE. Okay, so I did a side, an angle. Now I need another pair of sides. Let's see, so we did this side and this angle. The two green ones were given, but we haven't done the blue one yet. Well, that's DB, segment DB. And we say that DB is congruent to DB. By the reflexive property. Okay, now once we've said and listed our sides, our angles, and our sides, the next thing to do is to say that the triangles are congruent. So now we can go ahead and say triangle DAB is congruent to triangle BCD. Okay, and of course that's the side angle side postulate as we knew. Okay, now finally we can, now that we've shown that the two triangles are congruent, now we can zero in on this pair of corresponding parts. So I can go ahead and say the thing I'm trying to prove. AD is congruent to CB because corresponding parts of congruent triangles are congruent. Number 24. All right, we seem to be finished with the proof part of the story. Now we're solving for variables given that these triangles are congruent. Well, if these triangles are congruent, then their corresponding parts are congruent. For example, angle B is congruent to angle F, which means, of course, that 8x minus 14 should equal 5x plus 10. Let me zoom in. All right, to solve this, we need to get the x's together. So let us subtract 5x from both sides. So that's going to give us 3x minus 14 is equal to 10. Let us then add 14 to both sides. And that will give us 3x is equal to 24. Then it is time to divide both sides by 3. And that will give us x is equal to 8. All right, so that's one of the things we're supposed to find. All right, let's talk about z. These two segments are corresponding sides, so that means z squared should equal z plus 12. I see the z squared and the z. There's no way to get z by itself, so I'm going to get everything on one side. So I am going to subtract z from both sides. Wait, I meant to do that in another color. All right, I say I'm going to subtract z from both sides. Okay, so that way those cancel out. But I'm also going to subtract 12 from both sides. All right, so everything is gone from the right-hand side of the equation. So, copying that over, I'm going to have all of this. I'm going to have z squared minus z minus 12. And because everything canceled out, that's going to equal 0. And the way you solve this is by factoring. So z squared factors as z times z. 12 is either going to be 2 times 6 or 3 times 4. Or it could have been 1 times 12 as well. Let's go with the 3 times 4 option. Right? Because the inner plus the outer has to equal the middle. And the middle is a negative 1 z. All right? So we need it to be negative 1. So if we let the inner be positive 3 and the outer be negative 4, then inner I have 3z and outer I have negative 4z. Together they make negative 1z. Okay, or simply negative z. And that's what we have in the middle, so that's what we wanted. Also, we need this times this to equal that. 3 times negative 4 is negative 12, so that's cool. To find the actual answers, though, we need to take a step further and set these factors equal to 0. So z plus 3 equals 0, or z minus 4 equals 0. On this one, we need to subtract 3 from both sides. On this one, we would add 4 to both sides. So this will give me z equals negative 3, and this will give me z equals 4. So we just have 2 answers for z. All right, and if you substitute them both back in, they both work. All right, they both give you equivalent values for the side lengths. All right, so there's our z value. Now for our y value, we're going to have to do a little bit more work than this, because the y value seems to refer to this angle right here. And the corresponding angle is here, and we don't know it. So what we're going to have to do is figure out what the angles actually are. And we can do that by plugging in the value we got for x. If x is 8, then, for example, if I plug that in right here, then, then that makes this 8 times 8 minus 14. Well, 8 times 8 is 64. So that's 64 minus 14. So that is 50. All right, that's 50 degrees. So this angle here at F is 50 degrees. All right, so if this is 50 degrees, and this is 100 degrees, so far that is 150 degrees. It all has to add up to 180, so that leaves 30 more degrees for this guy. Okay, so that means this angle has to be 30. So that's the expression for y plus 20. So these two have to be the same thing. In other words, y plus 20 has to equal 30. So when you subtract 20 from both sides, you get y equals 10. All right, for number 26, All right, they're giving us all this information, but I don't feel like I have enough space to work it out here, so I'm going to work it out on scratch paper. All right, here we go. They say triangle MNO is congruent to triangle PQR. So we might as well just draw some triangles. So, all right, this would be triangle MNO, and that's supposed to be congruent to triangle PQR. What else you got? The measured angle P is 5x minus 9. Okay, so this angle right here is 5x minus 9. The measure of angle M is 4x plus 5. Okay, so this is supposed to be 4x plus 5. And furthermore, segment NO, or the distance between N and O, is 2x plus 40. I'm sorry, 2x plus 4. NO, okay? So let's see. So this will be 2x plus 4, okay, right there. Now we're supposed to find x and find QR. Okay, well, let's find x first. So these two angles should be congruent because they're corresponding parts. So that means that 5x minus 9 should equal 4x plus 5. Okay, so let's subtract 4x from both sides. And that's going to give us x minus 9 is equal to 5. Okay, then you can go ahead and add 9 to both sides. And that will give us that x is equal to 14. All right, so keep that in mind. X is equal to 14. That's one of the things we were supposed to find. Now that I know that x is equal to 14, I can substitute that in right here. All right, I could put that 14 in there. So if I do that, then this is going to become 2 times 14 plus 4. So that's 28 plus 4. So that's 32. Okay, so this side right here, this NO, is 32. But the NO is corresponding parts with the QR. So if NO is 32, then QR is also 32. So I believe we were supposed to find x and the distance from Q to R. So that's 14 and 32. All right, here's the last problem. It's very similar to number 26, except for I might actually have enough space to do it. All right, they said triangle ABC is congruent to triangle DEF. Okay, so we'll call this ABC, and we'll call this DEF. All right, AC is 2x plus 7. So that's going to be 2x plus 7. DF is 5x minus 5. That means this will be 5x minus 5. And EF is 5x. Okay, I'm going to switch colors on that one. So EF is 5x. we're supposed to find x and then find EF. Well, similar to last time, these are corresponding parts of the triangle. So, of course, the 5x minus 5 should equal the 2x plus 7. So subtracting 2x from both sides, that's going to give us 3x minus 5 is equal to 7. Then if you add 5 to both sides, that's going to give us 3x is equal to 12. And then you would divide both sides by 3. And that's going to give you x is equal to 4. So that's one of the things that we were supposed to find. Alright, but now that we found that, we're also supposed to find the distance from E to F. But now that we know that x is, what did I say it was, 4, I can plug that in. Alright? So if x is 4, then that means this is going to equal 5 times 4, which is 20. Okay, so that means EF equals 20. And that's the end of this lesson. I hope it was helpful for you. I will see you on the next video.